As your stall training progresses, you'll be introduced to several aspects of stall spin awareness. Although you are not required to demonstrate spin recovery on your private pilot practical test, you are required to have a thorough understanding of spins and spin recovery techniques. Your training in this area consists of both ground and flight instruction. The ground training portion includes instruction in the areas of stall awareness, spin entry, spins, and spin recovery techniques. Then, as your flight training progresses, further emphasis is placed on stall recognition and recovery, and realistic distractions are introduced during flight at critically slow airspeeds. It's important to remember that actual spin training is not required, and under no circumstances should you practice spins or spin recovery techniques without a certified flight instructor on board. Accelerated maneuver stalls are a variation of power-on and power-off turning stalls. Although not included in the private pilot PTS, your instructor may demonstrate how an airplane can stall at higher airspeeds due to the additional load factors created by a steep turn. For example, in a 45-degree level turn, the airplane's effective weight is 1.4 times greater than in level flight. This means that if the normal stall speed for a particular airplane in straight and level flight with flaps up is 50 knots, it will stall at 59 knots in a 45-degree level turn. Before beginning an accelerated stall, clear the area. Then verify that the airspeed of the airplane is below the published maneuvering speed. This will avoid placing high structural loads on the airplane during the maneuver. Next, roll the airplane into a level bank of approximately 45 degrees and firmly increase back pressure on the control wheel to initiate a stall. Normally, you will recover at the first indication of a stall by releasing back pressure while simultaneously adding full power. Then, use the flight controls to keep the airplane coordinated as you level the wings. A crossed control stall is most likely to occur during a poorly planned and executed turn from base to final approach, and is often the result of overshooting the extended runway centerline during the turn to final. Even though flight proficiency in a crossed control stall is not required, it will be demonstrated to you by your flight instructor. The important thing to understand is not how to perform the crossed control stall, but to be able to recognize its onset and the procedures necessary for a safe recovery. A crossed control stall will occur when you apply aileron pressure in one direction, rudder pressure in the opposite direction, and use excessive elevator back pressure. Stall should be practiced at an altitude that will allow you to safely complete the stall recovery no lower than 1,500 feet above ground level. For this demonstration, we'll check the area for other traffic, reduce the power, then maintain altitude until the airspeed approaches the normal glide speed. Flaps should not be lowered during this demonstration because of the possibility of exceeding the airplane's limitations. Once the glide attitude and airspeed have been stabilized, roll into a medium bank turn to simulate a final approach turn with an overshoot to the center line of the runway. Continue the turn while applying full rudder input in the direction of the turn. Maintain the bank by applying opposite aileron pressure to stop the overbanking tendencies, while slowly increasing back pressure on the elevator to keep the nose from lowering. When the airplane stalls, release the pressure on the flight controls and then increase the power as necessary to return to straight and level flight. In a crossed control stall, the airplane may stall with little or no warning. The nose may pitch down and the inside wing suddenly drop. The airplane may continue to roll into an inverted attitude. This is usually the beginning of a spin and can be very dangerous at lower altitudes. Early recognition of the characteristics of a crossed control stall is very important because recovery may be impossible due to the altitude needed for a safe recovery. The demonstration of an elevator trim stall will show you what can happen when full power is applied during a go-around from a normal landing approach, a simulated forced landing, or immediately after takeoff with an improperly set takeoff trim setting.
Whenever we're practicing stalls, John, one thing you've got to remember, according to the PTS, is that we must recover from a stall no lower than 1,500 feet AGL.
Even though flight proficiency in an elevator trim stall is not required, it will be demonstrated to you by your flight instructor. The important thing to understand is not how to perform the elevator trim stall, but to be able to recognize its onset and the procedures necessary for a safe recovery. You will also learn the importance of making smooth power changes, how to overcome strong trim forces, and how to maintain positive control of the airplane in a go-around environment. After clearing the area for other traffic, slowly reduce the power. Lower 1/2 to full flaps. Then set the power to idle. Maintain altitude until the airplane slows to the approach glide speed. Once established in a glide, simulating the final approach path to the runway, smoothly advance the throttle to the maximum allowable power as you would in a go-around. To recover from the approaching stall, apply positive forward control pressure to lower the nose, maintaining directional control with aileron and rudder pressure. Maintain forward pressure until a normal climb airspeed and attitude can be established. Then retrim the aircraft to remove excessive control pressures. It is imperative that a stall does not occur when full power is applied during a go-around from a normal landing approach, a simulated forced landing, or immediately after takeoff with an improperly set takeoff trim setting, because the amount of pitch change and altitude needed for a recovery may be inadequate. From this demonstration, it is apparent that stall recognition is important, and prompt recovery procedures should be implemented immediately to prevent a fully developed stall condition.